Okay, this is the M1 paper from October 2023. This is question number 6, and as you can see as I'm scrolling this up and down, this is a vectors equation. Specifically, we're going to be doing a lot of work on vector equation of a line. So let's see what we've got going on. For part A, it says we've got this ship P which sets off at 12:30, and at that time it's at 15I plus 36J. Half an hour later, so it's 0.5 hours, half an hour later, it's at 20I plus 34J, and what I need to do is to work out what the velocity is if it's a constant velocity. So let's just explain the theory behind this stuff. So part A, what we have then, what we always have for these vector equation questions is, well, let's tell you what it is. R equals R0 plus VT. That's my vector equation of a line. What does that mean? It means that I know that it would start off from a particular place R0. It's then going to be going with a velocity of V. So it's going to be going in that direction. And I want to know where it is at certain periods. R are those red lines there. R is that red line there, which is R0 plus one lot of velocity, or R0 plus two lots of velocity, or etc., plus three lots of velocity as we're going through. So where am I at any stage? I am start off at R0 and then go up the line, go however many V's to end up in my position. That's just a really basic idea behind where R equals R0 plus VT comes from. So given that scenario then, I've got R equals R0 plus VT, and what do we know from this one? We know where it is at the start. R0, they told me in the question, was 15I plus 36J. I know that it takes half an hour, 0.5 hours, and I actually know the R. I know where it's going to be. I'm going to call it R. You could even call it R half if you wanted, or R 0.5. But R is where it ends up after that half an hour. It's at 20I plus 34J, so I can just sub all of those values in. So R equals R0 plus VT is going to give me 20I plus 34J is going to be equal to R0, 15I plus 36J, plus V times 0.5, so plus 0.5 V here. Well, let's subtract the 15I and the 36J. I'm going to get 5I, what's that, minus 2J is going to be equal to 0.5 V. Okay, so V is just double that. So V is 10I minus 4J, and that's what they asked me to show there. 10I minus 4J is the velocity for the first part. Okay, for part B, it says at time t hours after the position vector of p, little p, is given by i's, j's and t's, can we say what that is? Well, yeah, that's exactly what I've just said here now. So if we do part B, that should be pretty straightforward here, that I'm going to say R equals R0 plus VT. So they're saying, where is it going to be generally after time t? They're telling me it's at P. Well, that's going to be, where did we start off from? 15I plus 36J. And then we now know our velocity. Our velocity is 10I minus 4J times t. So I can write it like that. That's fine. That would be the answer. Another way of doing it, just because of the work we're going to do later on, is we can say that's 15I plus 36J. That's plus, if I multiply that out, 10TI and 4TJ, and then I could collect it in terms of i's and j's. So it's actually 15 and 10TI, and then 36 and minus 40J. This is absolutely fine. This is perfectly correct. Sorry, or over either of those two above, that one is as well. Both of those are correct. The only reason I've written it like this is that will help me with future parts of the question, because I know the sorts of questions that we're going to get here. Right, so we've got P done, and here we go. So it says a second ship is also travelling, and it tells me what's happening with that one. T hours after 12, it's given by that. So you've got these two ships both moving, and it says if these ships maintain their course, then they're going to collide at 1:30, and they're asking me to show that that happens. So what I'm going to do is if it's at 1:30, that would be T equals 1.5 hours after 12 o'clock. So if I find out where Q is at that point by putting T equals 1.5 in, and I then find out where P is by putting T equals 1.5 into that one, I'm hoping that they're going to work out to be the same as each other. So let's do that. Let's tell the examiner what I'm doing as well. So at T equals 1.5, P will be equal to 15 plus 10 lots of 1.5 I plus 36 minus 4 lots of 1.5 J. And if you work that out, that actually works out to be 30I plus 30J. Let's see where Q is. Q is going to be equal to, Q was 42 minus 8T. So 42 minus 8 lots of 1.5 I. And it was 9 plus 14 lots of T J. And that also works out to be 30I plus 30J. So therefore, the two ships collide at 30I plus 30J. Now, the only reason I've said that last part is that I've read this question before already, and it says, what's the position vector at the point where they collide? Yeah, so the position vector is given by 30I plus 30J. That one there. So we've answered part 1 and part 2 there for C. Okay, for part D then, yeah, it's worth 7 marks here. Just need to probably explain this. What it says is, okay, so it would have collided, but actually at 12:30, Q is going to change speed and direction to avoid the collision. So at 12:30, we need to work out where Q is, and then once we've got that, we need to work out what our new vector is going to be for it. So let's start off by doing that. So for part D, and for Q, let's work out where it is. So at 12:30, that's T equals 0.5. If I put that into the current version for Q, so 42 minus 8 lots of 0.5 I, and 9 plus 14 lots of 0.5 J there, we know that it's at 38I plus 16J. So it does that to start off with. That then is my, if I'm doing R equals R0 plus VT, that's going to be my R0 or my Q0 if I'm doing Q equals Q0 plus VT. So if I want to now work out the where that's going to be, what I'm going to do now then is to say, let's call it RQ maybe. RQ is going to be equal to 38I plus 16J plus VT. Well, what's the new velocity? It's telling me that it's going due north at 15. So if it's going due north at 15, that's going to be 15J. And that's a pretty standard sort of one that they do for this. So it's going to be plus 15JT for where Q is going to be. If I want to know where P is going to be at that point, for P didn't change at all. So I already had P as 15, this one here, as 15 plus 10T and 36 minus 4T. So there I can just put in at 2:30, where is that going to be? So for P at 14:30, Now remember, RP was equal to, what did we just say it was? We already had it as 15 plus 10t I and 36 minus 4t j, and I'm now going to find out where that is at 230. So at 230, that's going to be t is going to be equal to 2.5, isn't it? So if t is going to be equal to 2.5, that's going to be equal to 15 plus 10 lots of 2.5 I, 36 minus 4 lots of 2.5 j. Complicated question, this one. So RP is going to equal to, if I work all that out, it's going to be 40i plus 26j. Now I've got to be really careful with this next one for Q at 1430. Don't forget that it changed at 1230. So it's only been doing this one for 2 hours, not for 2.5 hours. That's a nasty little extra that you just stop and rewind the video and go back and have a think about that. So when I'm working out what Q is, yeah, it's going to be 38i plus 16j plus 15jt, but the issue is that t is going to be equal to 2, not equal to 2.5 when we're trying to work that out. So that's going to be 38i plus 16j plus 15 times 2 here when we're doing that one. Sorry, with the j. Plus 15 times 2j there. So that's going to give me, just work that out, that's going to give me for Q 38i plus 46j. So I've now got where these two are going to be at 1430, and then it says it wants to work out the exact distance. So if I want to work out the exact distance, I can do that when I've got the 2 points. So the distance between 2 points is equal to square root of x2 minus x1 squared, y2 minus y1 squared, and we can just put in, given those values there, so 40 minus 38 squared, 26 minus 46 squared, square root, and they wanted it as the exact one. It works out to be root 404, which works out to be 2 root 101. Is it kilometres? What is it? I think it's probably kilometres in this question. Yeah, kilometres. So really nasty little bit there right at the very, very end. But apart from that, it's question 6. You know, it's going to be a difficult question when we get to this sort of stage of an M1 paper. Read through it a couple of times, listen to it a couple of times. Hopefully that all makes sense to you.